Hello guys, let's welcome to our channel Just Genius. In the last video we have completed the big O notation. In this video we are going to start big omega notation. So I recommend you to watch the big O notation first. Before starting the big O omega notation, if you know the big O notation, it is simple and easy to understand big omega notation. Only the inequalities, that means equality changes, all remaining parts is the same. Definition is also some changes, some part changes. Okay, so I recommend you to watch the big O notation first. So let us start our video now. So when you look into this big omega notation, first similarly we will discuss how we have discussed in big O notation. Okay, I will write definition here. So I will write definition of this big omega notation. So definition, let f of n comma g of n be two non-negative functions and f of n equals to big omega of g of n. Big omega of g of n if there exist two positive constants. So you know what are those two positive constants, c and n naught, as you know in big O notation also, such that f of n greater than or equal to c into g of n. You can remember it's c into for all n greater than or equal to n naught. So when you look into in the big O notation, f of n is less than c into g of n. Here f of n is greater than or equal to c into g of n. Okay, that difference changes. I will show if you see the complete definition of this one. So when you look into the complete definition, so we take in the two positive functions, means two non-negative functions, means those are called positive functions. Two f of n, g of n, two positive functions. Here you can observe f of n equal to big omega. This is omega symbol, like this. It will be like this, omega symbol. It will be like this. Okay. If there exist two positive constants, c and n naught, such that f of n greater than or equal to c into g of n. Whereas in big O notation, f of n is always less than c into g of n. Okay, or equal to. So if you compare the both definitions of big omega and big O notation, you can identify easily. So I recommend you to watch big O notation once again. So when to use this big omega notation? So I will come into once again that slide. So when to use this big omega notation? Big omega. So when to use this big omega means big omega is used in lower bound conditions, lower bound scenarios. Okay. So lower bound scenarios, that is big omega is used in best case scenarios. So what do you mean by best case or worst case? You know, I think. Otherwise we will start another video. So if you don't know, please comment it to best case or worst case we need. Okay, we will make another video related to best, worst and average case. Okay, best case scenario means generally it take less time complexity. The time will be taken less, the amount of time is less. That is nothing but best case. Just remember, the amount of time will take is more. That is worst case. Whereas big O notation is used, the time taken by this large big O notation is used, the time taken is small, and best case, that is big omega notation is used. Just remember these two things. Okay, so that's it. Now when you look into once again this one, you will look into this graph. So when you look into this PPT, so if you want to say running time is at least, then we use big omega notation. So at least means here we are going to say about time taken less, so we use the big omega notation. Okay, big omega notation is used to express lower bound conditions. As I told, it is used to express lower bound conditions. So if you look into this is the definition. This is the definition of this big omega notation. So according to definition, we can draw the graph related to big omega notation. This is the graph. So I will explain this graph. So I will explain here. I will explain this graph. So the slide is better than explain. Okay. When you look into this graph, so according to big omega notation, we know that f of n always greater than or equal to c into g of n for all n greater than or equal to n naught. Okay. So when you compare these two, here f of n is above of c into g of n. So okay, so condition is satisfied. So after this n naught, so n is greater than always n naught. So before this n naught, Similarly, two conditions can happen when you observe at this level here, f of n less than c into g of n. Okay, observe once again the graph carefully. F of n less than c into g of n. Okay, that means c into g of n is greater than f of n. After this one, if you observe this here, this area, f of n greater than c into g of n. F of n greater than c into g of n. Okay, understand? Before n not two conditions can happen: f of n greater than c into g of n and f of n less than c into g of n. So if you look into the graph once again, you can understand it easily. Okay, so that's it about the big omega notation. In the next video, we can solve the problem related to big omega notation. One problem related to big omega notation. Okay. So the each and every material of these data structures and algorithms will be uploaded in the description box. You can access the drive link from the description box. So if you like this video, please like, share and subscribe. So also in the description box, I have given a Google drive link to comment on how I teaches. So please make sure that only just one review, it takes less than 1 minute. So you can, I think I hope that you fill this form. So we have completed this big omega notations. Just once again we'll see. Just once again we'll over it. Oval review. So big omega notation is used in lower bound conditions and also best case scenarios, and also big omega notation it takes less time. The amount of time is less. Okay. So amount of time is less. Also we have discussed the graph related to big omega notation, and also this condition make sure about this condition. Also this one. Okay. Okay. Thank you.